Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast, back with another article review. Today, I want to talk about a really interesting new study testing some of the ideas, they call it a proof of concept of testing some of the ideas put forth in when we take a dynamical systems approach to injury. And if you kind of follow along, and this was something I covered in episode 490, right? Trying to understand a sport injury from a dynamical systems instead of creating a linear model where there's risk factors that have a direct effect, a predictable deterministic effect on injury, which don't work very well. Using a complex systems approach where we look for changes and patterns of coordination, critical fluctuations, as they're called, as predictors and possible precursors to injury. And this is a paper published in Sports Medicine. It's called Critical Fluctuations, the Early Warning Signal of Sports Injury. So have a listen to that episode if you want the full background of this idea. So the idea is that in a complex system, like a human being, an athlete, there's certain tipping points where abrupt changes occur, right? We call these phase transitions. Sometimes we call these bifurcations, where we go from one attractor state to another. We make the sudden change in the pattern of coordination. The idea into when we talk about injury is that injuries occur as a result of these phase transitions, right? There's also obviously when we're learning a new skill, there's healthy reasons to do this, but over the long term, when we jump out of a tractor state into another, that can be a precursor to injury. Okay, um, that's the idea. That's what leads up to an injury. That's kind of the idea here, and that prior to these kind of phase transitions occurring, you get a point of instability around the attractor, around the movement, and before that occurs. So the idea here is that we can maybe we can predict it in the potential for an injury by monitoring variables, looking at the complexity, their stability, detecting these points of instability early on, and then seeing how they relate to injury, right? Critically, and related to a lot of things I talked about at the end of last year, right? This, of course, obviously has to be done on an individual level. We're talking about individual stability in performance, not a mean level, group level, right? We're looking for these critical fluctuations, these critical changes in the state or the complexity of variables that will predict these phase transitions. That's the idea here. Okay. So this is as I talked about in that episode I mentioned earlier. This occurs in a lot of other fields, right? You can see these kind of critical fluctuations before large changes in the economy. And there's these periods of instability or critical fluctuations that occur before, and these are called early warning signals. So the idea is you have a non-injured athlete that can jump between multiple states. We get this period of instability where they're not in any one state, they're kind of jumping between. This predicts, and they're moving towards a new kind of attractor state. This is what result when they move to this new attractor state, maybe using different sets of muscles, different coordination solutions. This is when they get injured, right? This period of instability might be an early warning signal we can use to detect the injury. Okay. And in that episode, I also talked about this really great paper called "Early Warning Signals for Critical Transition" by Sheffer et al., a Nature Review paper that talks about how this has been applied to a lot of different fields of economy. This figure I'm showing up here is how you can predict epileptic seizures by looking at before they occur by detecting these critical states of instability, right? So what we're seeing is variability, right? We're seeing instability, right? In the ecological approach, we talk about good variability. This example of bad variability, it's instability when we're transitioning from a stable, effective attractor state into a less stable, into a different one that could potentially cause injury, right? So not all variability is good, of course. Okay. So in this study, they want to test this idea, okay? Test this idea of using these critical fluctuations as early warning signals. They're using youth soccer or football players, right? So what they're going to do is monitor several psychological and physiological variables of individual players on a daily basis, right? That's the key to this, right? We need lots of data points over a long time period for individuals, and we need to detect these to be able to detect these critical fluctuations. The main measure they're going to use in this is something called dynamic complexity, which I must admit I've never heard before, so I'm not exactly sure what it is. As opposed to some of the Hurst exponent and some of the other things I talked about in the other young controlled manifold, some of the other thing, index of synergy, some of the other variables I talked about in that other episode I mentioned. But this seems to be an interesting measure, and they do show it. It has been used in some previous research, right? So what their main hypothesis is, this critical fluctuations, these peaks in the dynamic complexity, this measure will precede the occurrence of an injury. So they're going to measure these players for a long time. They're going to take a large sample. The ones that will notice when they get injury, then go back and look at these data. Okay, they're going to explore. Several different factors, some psychological things in self-report, and also some physiological things measured by sensors to look for these stabilities. So I think it's a really great idea, really interesting idea, really test and proof of this concept. Okay. So they're going to start with 55 male players from under 18 to under 21 teams. So they're 16 to 20 years old. They're from the Netherlands, right? Every day they're doing self-report questionnaires based on their motivation, their mood, their perceived exertion, their total, how much they feel recovered, right? So they're doing kind of questionnaires based on these. The authors recognize to keep this manageable, most of these are assessed by one item, right? One question. How much do you feel you recovered, right? The authors recognize the limitation of this, right? People can kind of see through the things you're doing. Usually to effectively use questionnaires, you need multiple measures, right? So they're doing these every day in the locker room. Also during the game, they're wearing several sensors, GPS sensors, heart rate sensors that are giving them physiological data like how far they ran, how many accelerations they did, how many sprints they did, their heart rate, and things like that. Right? So they're going to take all these variables, measure them every day, and look for these critical fluctuations. So they're looking at the time series, like in most dynamical systems analyses, looking at the time series of the data, how these variables change across time, not averaging them, not combining them across groups. Okay. So here's an example, question: how good is your recovery? Score from, recovery, motivation, mood. How much did you run? Enjoyment. Okay. Those are the things I talked about, examples of the questions. Okay. In the end, out of the 55, there was 23 that were included in the end analysis. Why did it reduce in half? Because in order to be included in the analysis, obviously they had to have had an injury. Okay. So 23 players had at least one injury between the kind of the start of the measurements, the first 7 and the last 7. Right? So giving them enough to measure these critical fluctuations. So they had 23 players in the end. So that's the kind of the basic method. So again, a lot of incredible amount of work, obviously, going in this, a lot of data, right? What did they find, right? So before that, to analyze it, they first normalized all the variables to a score of 100, so they're comparable. Without going into a lot of details about what this DC measure is, it measures the fluctuation in the time series and the deviation from the maximum and minimum values. So it's kind of looking at the time series of the data, how it's going up and down, and looking for these very large changes. Okay, whether there's kind of peaks at different time series. Okay, and they're going to look at how this precedes injuries. Okay, so that's the basic design and what they did. What did they find? Overall, the study players got injured roughly 3 times during the measurement period on average, right? Not everyone got an injury, as represented as why there were only 23 participants, right? What they did, and the first thing they did was they showed data for 2 kind of exemplar participants, ones that really fit the model. What they showed is so if you're watching the video, if not, I'll just describe it. But here is the time series of the data, right? So your self-efficacy ratings are going up and up, up and down, up and down. Your heart rate is going up and down, up and down, and up and down, right? Your total distance you run is going up and up and down. And what they're looking for are critical fluctuations. So suddenly large changes in the kind of the amount of fluctuation, amount going up and down, to put it simply. Then from these data, they're measuring this dynamic complexity, right? This plot is showing all the variables. The yellow were when these players got injured in these 2 cases, right? And what they found for both these players, they fit the hypothesis. There was this kind of orange, these critical fluctuations preceded the critical instability, preceded the injury by a few time periods. Okay, so it does seem to support the model. Okay, so there's some interesting evidence. I'll invite you to have a look at more details of what exactly they found. But that's the basic idea. For some participants, they did find this overall pattern. Okay, so we get these complexity, and basically 30% of the cases of injury, you got this kind of detection of this early warning signal, this kind of this fluctuation in these measures, right? And there were roughly 6 points before the injury occurred. That's where they're looking. So 19 out of 64. So in 30% of the cases, they were able to successfully predict the injury based on these fluctuations, which seems pretty good. But overall, when you kind of combine in a sensitivity model analysis, you combine the number of times they indicated at a 64, there was a true positive. There was also a very large number of false negatives, right? So fluctuations that did not lead to an injury. So overall, the model, this kind of variables ability to, based on these variables that collected, to identify the positive cases where there was an injury was quite low. Okay. So the model, as again, it's a great first attempt, but obviously there more work needs to be done, right? To find the variables to use, what point in time to measure them, and so on. But I think for a first attempt, it's interesting, a proof of concept. There was no consistent in terms of which variables mattered, whether it was the psychological ones or the physical ones like heart rate and things. There was no consistent trend, right? The ones that did occur, fluctuations that did occur before injuries, tended to be a lot of different variables, right? So the bottom line is the model worked in theory. Overall, it didn't do a great job of distinguishing between injury and non-injury. Still needs some work, right? So the final discussion, the outcomes of the study were twofold. As hypothesized, there were critical fluctuations quite often before injuries. Roughly 30% of the time, the model successfully predicted an injury. Again, 30% of injuries, 19 out of 64, and there wasn't in a large number of the non-injury cases. But overall, obviously, a lot more work needs to be done in terms of what things we measure and things, because the overall model's ability to discriminate between non-injuries and injuries was rather poor. For it to be a practical value, for it to justify collecting all this data and analyzing it, it's not quite there yet, right? It still needs some work, but I think it's a really interesting proof of attempt and proof of concept of this. I think really valuable and makes a lot of sense to me idea that these changes in coordination patterns, these critical fluctuations are going to occur well before the actual injury occurs. I think that looking there, I think there's a lot of value of that in the future. So that's it for today's episode. I think it's, as I said, a great first attempt. I hope there comes a lot more work in this area. I think it's a very valuable and fruitful line to pursue. Thanks for joining me. Cheers for now, and keep them coupled.